Welcome to Statistic 1, Chapter 6, the normal distribution. Topic, basic concept of the normal distribution. So at first we would have to understand what is a normal distribution first, and then we will work on specific part related to the exam and the curriculums of S1 later on. So first of all, for random variable, random variable. And I mentioned before, we have two kinds of random variable. One is discrete. The second one is continuous. Continuous. So when we have learned about the binomial distribution. When binomial distribution represent the discrete random variable. So the normal distribution will represent the continuous random variable. This is a difference between these things. So for the binomial, it represents some specific value like 1, something like 2, something like this, 3. It take on specific values that we can count for them. But for continuous random variable, like for example, is the age of people in a country. We got a lot of people in a country, and for the exact age of X people, we cannot identify what is that exact age. We can say a person is 175 centimeters tall, but actually that person can be 175.0496210. Something that we cannot take on any specific value because this one will go to infinity. And then we just can do our best to get the range about something like this, 105, 0.4 to 175.5. It's in between here. So it's in between some interval. We cannot take the exact value, so they are continuous there. When we plot the continuous there, we'll have our normal distribution. Like for this one here, the mean age of a country is 168 centimeters tall, and we plot the number of people, which is 158 centimeters tall, is in here. This line is the numbers of people, which is 168 centimeters tall. Now this is numbers of the people, which is 167 centimeters tall, and numbers of people, which is 166 centimeters tall. And here is 169, 170. When we plot it a lot, we represent the data a lot with a lot of age, like this, and we connect the top of each line with each other. We'll get something like this. This one is called the normal distribution curve. Normal distribution curve. This one. So now I will tell you more specific about the normal distribution curve. Now I will talk about the normal distribution curve. So I have a scale line here, scale line, a line, straight line, and I will draw a normal distribution curve. It will be something like this. Be something here. This is my normal distribution curve. So I have three things that you have to remember about my normal distribution curve. The first thing, it is a bell shaped curve. Look at this one, it looks like a bell, so we call that a bell shaped curve. And that is one of the most important things that you have to remember when you think of a normal distribution. The second thing I want you to remember is that when this one go to infinities, and this one also go to infinities, and this line will never touch this line, To what extent this line will never touch this line. So like we have the number of electrons of everything. It can be 1 electrons in the hydrogen, and it can be a billion, trillion, or some number that we cannot count from a planet, because we mentioned here is a number of electrons in anything that we can think of. So the second thing I want you to remember is that the total area under the curve to this line, total area equal to 1. Including the tail, it goes to infinity, and this one goes to infinity too. So the total area is 1. Here, this part. This one, the total area of this part is 1. Always 1, never change. And the third thing I want you to remember is that it is symmetrical through the middle line. I would draw my middle line in here. Here, a line in here. This is my middle line, so it is symmetrical. So the area from here is equal to area from here. So yeah, they're equal because this one is symmetrical through this line.